Well, today I am going to start my series on 3.9 Bivariate Investigation. So in this investigation at level 3, we are following the PPDAC investigation cycle. So our first part is to write a purpose and plan. One of the first things you have to do when you're looking at your purpose is to try and find a pair of variables that will actually suit you and you may have some interest in, because it makes the investigation easier to do. You can do this by looking at the Data Explorer in NZ Grapher and finding out one that actually has a strong relationship, or at least a relationship. And you need to do some research to find out, provide some research to back up what you are doing as your problem or your purpose. And you can include those links in your research. So this is an example of a purpose. Body image is a concern of modern women, and just as much for female athletes as it is for any women. Weight charts can be unreliable as a source for determining the healthy weight of athletes, and body fat percentages are sometimes used instead. Women tend to weigh in the top range for their heights due to their muscle mass being heavier than fat mass. During the 2012 London Olympics, the media reportedly criticised some female athletes, suggesting they were fat rather than fit. And a top athlete hit back the critics, saying, "Fat, we are fit, get over it." That was Belinda Goldstein. And here's a link about that particular incident. So when we are posing our problem, once we've done our purpose and decided what we're going to investigate, we have to actually ask a question in the correct way. For instance, what is the relationship between variable 1 and variable 2 for the population? So it's important to have those variables with units and the population stated here. Example, what is the relationship between the weight in kilograms and the body fat percentage of female athletes from the Australian Institute of Sport? The data was collected in 2019. Now, you don't ever ask, is there a relationship? Because there is always a relationship, whether it is a really bad no relationship. So we always ask, what is the relationship? Next, you state your hypothesis. So figure out what you think is going to happen before obviously you've looked at the data, but have a good hypothesis or a good think about why you think this relationship is going to be in existence. Okay? And finally, state the purpose of your investigation. Who do you think it would be useful for? Why would it be useful? So if we have a little look at the Census NZ 2009 on New Zealand rugby players, and we have got an example here. So your question would be, what is the relationship between the weight in kg and the height in centimetres of New Zealand rugby players in the data provided by Census New Zealand in 2009? Your hypothesis, I think that there will be a strong relationship between weight and height of New Zealand rugby players. I think this is because research from blah-de-blah-de-blah says that taller rugby players tend to be in the forward position, which require a larger body mass. State the purpose of your investigation. This investigation will be useful for people who want to play rugby, as it would help them determine what position may be best for them to play based on their height and weight. Okay, a very loose one. Need a lot more in your purpose so that you actually have a good understanding of what you're investigating. Next, we look at the variables. So you might already know what independent and dependent variables are. So that's when you have a particular variable and another variable is dependent on what is happening to the independent one. We also use the words explanatory and response. So they basically mean the same thing. So our independent explanatory variable, that's the one that influences the other one and can sometimes, but not always, be the cause of the other variable's change. And the dependent response variable, that's the one that goes on the y-axis. This is the variable that's most likely impacted by the other one and is the focus of our investigation. It's very, very important that you get these ones on the right axes. Okay, so it's important that dependent one is on the y-axis and the independent one is on the x-axis. To help work this out, ask yourself which one came first or does not change based on the other. For our rugby players' data, for instance, it is very hard to change your weight. So we would say your height. So we would say your height is the independent variable, but there is some change in your weight depending on what you do with eating and exercise. So Therefore, weight would be our dependent or response variable. So we're going to look at, in this set of variables, the percentage body mass. So you need to identify your explanatory and response variables. And so in my case, the percentage of body fat would be the explanatory variable, and the athlete's weight would be the response variable. Identify what they're measured in. So are they measured in millimeters or milliliters or years or whatever? Body fat has a percentage and weight in kgs. In this particular information, we have to have measurement data. So we cannot have data that is numerical as such, discrete. And identify the source, so wherever it's come from. In my case, the Australian Institute of Sport. Okay, thanks for listening.